All right, hello everyone, and welcome to the AI Research Roundup. I'm your host, Alex, and today we're diving into some fascinating AI research. We'll be looking at a paper titled, Next Token is Enough Realistic Image Quality and Aesthetic Scoring with Multimodal Large Language Model, published just recently on March 8, 2025. So, the paper tackles a really relevant problem. With so much user-generated content online, how do we automatically assess image quality and aesthetics? Multimodal large language models show promise here, but it's tricky. A single score doesn't capture how humans see things, and getting these models to output precise numerical scores is still a challenge. This paper proposes a new dataset and method to address exactly that. Okay, and speaking of the practical side of this research, here we have a look at their GitHub repository. So, it's up and running. Right now, it seems to mostly have the project overview and links in the README file. But the good news is, they mentioned they're planning to release the RealQA dataset we just talked about, along with the model checkpoints and the code itself soon. So definitely keep an eye on that if you want to dig into the implementation details or use the dataset. Okay, so moving on. This first figure gives us a great visual breakdown of the concepts in the paper. On the left side, it shows those fine-grained attributes that make up the RealQA dataset annotations, categorized into low-level things like image clarity, middle-level like subject clutter, and high-level attributes like composition score. Then, next to that, you see example images from the dataset illustrating these different quality levels. The figure also shows the different chain of thought formats they use for the model's reasoning, and an example of how these fine-grained attributes help in real-world applications, like comparing different images. Okay, building on those fine-grained attributes we just discussed, this next figure really drives home their importance. What we're seeing here are bar charts showing the correlation, basically how strongly those predicted attributes relate to the overall mean opinion score, or MOS, on two standard datasets, Conic 10K for image quality and AVA for aesthetics. So for Conic 10K, attributes like image clarity and exposure show strong correlation, while for AVA, things like composition score and eye-catching score are most correlated. This tells us these attributes aren't just arbitrary. They genuinely capture aspects that influence human perception of quality and aesthetics. Okay, so building on those attributes and their relevance, this figure shows us how the researchers actually train their model. It's a two-stage process. Stage 1 is all about teaching the model to extract those fine-grained attributes we discussed, using their new RealQA dataset and those low, middle, and high-level categories. Then, in Stage 2, they take that knowledge and retrain the model on public datasets, combining the attributes with numerical scores using different chain-of-thought prompts, like asking for brief or step-by-step ratings. This stage uses techniques like LoRa fine-tuning on the QN model. Okay, so we just talked about that two-stage training, particularly Stage 2, where the model learns to predict numerical scores alongside those attributes. Well, this figure highlights a subtle challenge when predicting those numbers directly. Using the standard way of measuring the model's error, called cross-entropy loss, or LCE, can sometimes be misleading for scores. For example, if the true score is 3.99, a prediction of 4.01 is actually closer than, say, 4.99, right? But the standard loss might incorrectly penalize the closer prediction more. So, the researchers introduce a new metric called NCM, numerical continuity metric, which this figure illustrates to better capture how close the predicted number actually is to the true value. Okay, so we were just talking about predicting those numerical scores accurately. And this table actually digs into how many digits the model should predict for the best results. They call this M the number of digits. They tested predicting just the main integer part, M equals 1, versus predicting 1 or 2 extra decimal places, M equals 2 and M equals 3. And, well, the results are quite interesting. On the AVA dataset, predicting 2 extra digits, M equals 3, significantly boosted performance, increasing the SRCC score by about 0.096 and the PLCC by 0.101 compared to just M equals 1. The effect isn't really there on the ConIQ 10K dataset, but it shows that predicting with more precision can really help, especially for aesthetic scores. Okay, so we've talked about how many digits to predict for those scores. This table actually compares how the model predicts them. It pits the paper's chosen method, next token prediction, or NTP, against a more standard regression approach. Looking at the SRCC and PLCC scores, NTP clearly comes out on top. Even after just 2 epochs of training, NTP hits 0.939 SRCC and 0.949 PLCC, which is noticeably better than the regression method even after 6 epochs. So, this result strongly suggests that using the next token prediction mechanism is indeed a very effective way for these MLLMs to generate accurate numerical scores. Okay, so we just saw that next token prediction works really well for the numerical scores. Well, this table, Table 7, shows how their complete method performs overall on standard image quality assessment benchmarks, including some cross-dataset tests. It compares their approach, labeled ours, against other state-of-the-art methods on datasets like ConIQ, 10K, SPAC, and Live Challenge. And you can see, especially the ours version using chain of thought, it achieves really top-notch SRCC and PLCC scores, like 0.959 PLCC on ConIQ 10K and 0.898 PLCC on the Live Challenge cross-set test. This shows the whole system, the attributes, the COT, the NTP. It really works well together and generalizes effectively. Alright, so we saw the overall results are really impressive for this method. I think the big takeaway is really how effective using next token prediction within these large multimodal models can be for generating surprisingly accurate quality and aesthetic scores, really pushing the state of the art. It highlights the expanding capabilities of MLLMs in complex visual understanding. Okay, that wraps it up for this week. Thanks so much for joining me on the AI Research Roundup. I'm your host, Alex.